So since 2 pi radians is equal to 360 degrees, that means we can change anything in degrees to radians by using a conversion factor. If we want to change 40 degrees to radians, we would just multiply it by a conversion factor so that we get 40 degrees times, we could either use 2 pi equals 360, or frequently it's just used pi equals 180 because it's already reduced that way, right? So it makes your fractions a little smaller. So if we want to change degrees to radians, we put the pi on the top because that's the radians, and we put the 180 on the bottom because that's the degrees, and that gets our degree unit to cancel out so that we're left with the radian unit. Okay, so now we just reduce or divide with the calculator 40 over 180. And so let's see, we can at least get rid of 10 out of each of those, and in fact we can reduce that further to 2/9, correct? And then we would still have the pi, so we could just say that that is 2 pi 9ths radians. Now that looks a little weird, but the reason I write it that way is that pi is a transcendental number, it's an irrational number, it goes forever. If I multiply the pi into it, then I have to round it and get a decimal, which is okay, sometimes that's fine. Sometimes that's the kind of answer they want you to get, is to actually multiply it and get a decimal. But frequently we actually want to leave this exact. We don't want it to be rounded as a decimal. We want an exact portion of pi, because pi is a number that goes forever, that if we actually use the 3.1415926, we have to stop somewhere, and as soon as we do that, it's no longer exactly correct for the number of radians. Okay, so let's look at our circle here and start thinking about the radians in a circle and what they would be called. Of course, here we have 0 degrees. Well, it's also 0 radians. By the way, you know how we always put the little degree symbol on degrees? Usually we don't always, there's not a symbol for radians, and we usually don't write the word radians either. If they tell you that an angle is something and they don't put the degrees, then you can usually assume that it's radians. Now if we go all the way around the circle, that brings us back to the beginning, and we've gone all the way around and gone 360 degrees, or what is also known as 2 pi radians. Well, what if we want to figure out other angles that are on the circle? We can just take fractions of this amount, right? For example, halfway around the circle is half of 360, so it's 180 degrees. Well, what's half of 2 pi? Because that would be the number of radians that's halfway across. Well, that answer would be pi, because half of 2 pi is pi. So 180 degrees is equal to pi, which we just barely used when we did a conversion. Okay, let's think about a fourth of that, or a fourth of our circle. If we do a fourth of the circle, we're taking the 180 and dividing it by 2. So dividing 180 by 2 gives us 90 degrees, correct? Well, what do we get if we take pi and divide it by 2? Remember, we want to keep our answer exact, so we're not going to go 3.14159 and then divide by 2 and give a decimal answer, because that would not be an exact answer. Instead, we want to leave our answer as a fraction so that it is an exact answer. So 90 degrees can also be known as pi halves. So that means that this angle from here to here is 90 degrees, or pi halves. Add another 90 degrees to that, and you now have 2 pi halves. Here's one angle that's pi halves in size. Here's another angle that's pi halves in size, so that's 2 pi halves. And then if we go another 90 degrees to down here, we have 3 pi halves. Or if we go clear around to here again, we now have 4 pi halves. This number is not reducible, so that is what we call 90 degrees, is pi halves. This number is also not reducible, so that is what we call 270 degrees, is 3 pi halves. However, over here we have 2 pi halves. Well, that reduces to pi. So we always reduce our fractions and use the smallest reduced version. 4 pi halves reduces to 2 pi. So of course we're going to call it 2 pi instead of 4 pi halves. let's break this down into smaller parts. So again, we start at 0. If we go around here to 180, now let's break this into 30-degree increments. So in our 90-degree section, we have 3 30-degree angles. That wasn't as close as I would have liked. I'm just going to re-sketch that really fast. And then we also have 3 of those over here. Right? So there's 180 degrees, and I've split it into 6 equal pieces, because 180 divided by 6 is 30 degrees. So each of our angles in here is 30 degrees. So this one's 30, 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 this one's 30. So the angle that starts here and ends here, of course, is 30 degrees. Angle that starts here and ends up there is 60 degrees. 90 is our one at the top. We've already talked about that. This one here, we would add another 30, so it's 120 degrees. And the next one would be at 150. And then, of course, we get back down around to 180. Okay, well, remember how 180 is also equal to what we call pi in radians. So to get 30 degrees, we take 180 and we divide by 6, and that gives us our 30 degrees. What if we use pi instead? So pi, 30 degrees, pi divided by 6, would give us an irrational number with a decimal that we would have to round, and we don't want to do that. We want to keep it exact. So instead, we just take pi, divide it by 6, and write it as pi over 6, and that is our 30-degree angle. Well, then to go to the 60-degree angle, that's going to be twice this. It's 2 30s. And so if it's 2 times 30, then isn't it also going to be 2 times pi 6? And the next one would be 3 times pi 6, because we have 3 groups of 30. And the next one would be 4 pi 6. And the next one would be 5 pi 6. And the last one, of course, would be 6 pi 6. But let's keep going around the circle. So if we do another group of 30, or another 30 past there, it would be 7 pi 6. Past that, we have 8 pi 6. Past that, we have 9 pi 6. Then 10 pi 6. And last, well, not quite last, 11 pi 6, and then on to 12 pi 6 all around the circle, when we've taken that 2 pi and broken it into 30-degree increments. Okay, well now let's go through and reduce each of those fractions. Pi 6 is not reducible, so there's our answer. 2 pi 6 can reduce to pi thirds, because 2 6 is 1/3. 3 pi 6 can reduce to pi halves, because 3 over 6 is a half. We already talked about that one. That matches what we found earlier. 4 pi 6 would reduce to 2 pi thirds, because 4 6 reduces to 2/3. 5 pi 6 does not reduce, so that is the radians we used for that number. 6 pi 6 reduces, and of course that answer is pi, and we know that already. 7 pi 6 does not reduce. 8 pi 6 reduces to 4/3 pi, or 4 pi thirds. Either way, I guess I wrote that a little differently than I have been. This means the same thing. 9 pi 6, 9 6 reduces to 3 halves, so 3 halves, or 3 pi halves. That agrees with what we also talked about on the last page. 10 pi 6, they are both divisible by 2, reduces to 5 pi thirds. 11 pi 6 does not reduce. And then 12 pi 6, of course, reduces to 2 pi, as it should, because we are completely around the circle. So there are those particular angles every 30 degrees around the circle. Notice how every time you have an angle that's 30 degrees away from the x-axis, the bottom number is a 6. And that is a 30-degree angle away from the x-axis. The radians is a pi 6th. Anytime we have an angle that's 60 degrees away from the x-axis, it's a pi thirds. So we have pi thirds, and 2 pi thirds, and 4 pi thirds, and 5 pi thirds. Okay, I should have maybe done this on the last one I just talked about. But if we come back to this one really fast to finish up what I'm getting at here, we can also break down our 90 into smaller pieces of 45, right? So if we break down a 90 into half of what it is already, this would be 135. Half of pi halves would be a fourth. Or think of it this way, 180 degrees divided by 4 is 45 degrees. So pi, which is also 180, divided by 4 is also 45 degrees. So that's a pi fourths, correct? If we go another pi fourths around, so every 45 degrees is another pi fourths, we have pi fourths. We have 2 pi fourths, which reduces to pi halves. We have 3 pi fourths, which does not reduce. We have 4 pi fourths, which reduces to pi. Our next one would be 5 pi fourths, which does not reduce. That angle would be 180 plus 45, so 225 degrees. Our next one would be, since the last one was 5 pi fourths, the next one would be 6 pi fourths, which of course reduces to 3 pi halves. The next one would be 7 pi fourths, which does not reduce, and that would be our, add 45 to this, so 315 degrees, I believe, angle. And then around to the last one would be 8 pi fourths, which of course reduces to 2 pi.